Welcome to Linear Circuits. I'm Dr. Harris. The purpose of this lesson is to introduce you to basic circuit diagrams. They're important because anytime you have to analyze an electronic circuit, you'll probably receive the diagram for that circuit. And by analyze, you should really be able to look at the symbols and know what they mean. So by the end of this lesson, you should understand a basic electronic circuit. This lesson builds upon current, voltage, and resistance. Remember that current describes how electrons flow through a circuit. Voltage describes how the energy changes over time for those electrons that are flowing. And resistance describes how the circuit opposes the flow of electrons. Now let's consider a circuit diagram with basic elements. The first thing I want to point out are the wires, two of which are circled here. Wires are lines that connect circuit elements in the circuit diagram. In actual life, the wires might be pieces of copper that are connecting the different elements, but in a circuit, they're going to be basically lines. Wires also have zero resistance and zero voltage drop. We know that that's not true in life. Everything has some internal resistance, but for the basics of circuit analysis, we can assume that they have zero resistance and zero voltage drop. Wires also help to form nodes and junctions, which we'll discuss a bit more later. Now, the circuit elements that are present in this circuit are first, an independent voltage source. You see it has a plus and a minus with a circle around it. It's an independent voltage source because it's defined by the user. It might be 5 volts or 10 volts, but the voltage source is what it is regardless of what else is going on in the circuit. Later on, you'll learn about dependent voltage sources that actually depend on other factors in the circuit. The circuit also contains an independent current source. It's an arrow that's pointing in either direction with a circle around it. Now, please note that even though the plus and the minus are top and bottom in the independent voltage source and the arrow points up in the independent current source, these could easily be flipped. For the current source, the arrow could be pointing down. For the voltage source, the plus and the minus could be rotated such that the plus is at the bottom. It just tells you the reference direction for current flow or for the voltage drop. The other element, another element that's in this circuit, is a resistor. A line, a bunch of zigzag lines. It doesn't matter how many zigzags are there. That's the symbol for a resistor. And finally, you have a ground. There are several different types of symbols for ground, but these are the ones that we'll use throughout this course. And the ground gives you the reference direction. We know that voltage always has to have a reference direction, so the ground gives you the reference direction for that voltage. Now consider the difference between a node and a junction. A node is any point on the circuit where two or more circuit elements meet. Also important to know about a node is that nodes are only different if they have a different voltage. So remember, there's no voltage drop along a wire. So you have to go through a circuit element in order to have a voltage drop, and that's the only way you can have a different node. A junction, on the other hand, is the point where wires meet. So any given node might have several junctions along the same node. And this is a very important concept. So at this point, let's practice. Looking at this circuit, identify the nodes. How many nodes do you see? Also make a note of the junctions. Now remember that a node is where different circuit elements meet. So we have a node here. And the circuit elements that are meeting are the independent current source, resistors, and the independent voltage source. We also have a node here. Again, the current source and the resistors. And we have a node here. So this circuit has 3 nodes. And notice that the nodes are different from the junctions. We have places where the wires meet, so several junctions, which are typically represented by these bumps in the circuit diagram, or these little circles. But even though we have multiple junctions, we only have 3 nodes. Something else you should know about circuits is how to identify a short circuit. In life, we use that term haphazardly. We could say if something broke, then it probably had a short, some electrical short. But it actually has a very specific meaning. A wire that has the same start and end node as another circuit element shorts that element. And the reason shorts are important to recognize is because current will always travel through the short instead of that circuit element that the wire is shorting. Now, sometimes shorts can be introduced on purpose. Say you just want to ignore part of your circuit. You can introduce a short at the same start and end node for that part of the circuit, and current won't travel through that circuit. However, if you accidentally introduce a short, then your circuit is not going to behave in the way that you want it to. The opposite of a short is an open circuit. Opens are also very important to recognize, whether you've introduced them intentionally or unintentionally. An open circuit has terminals that are not connected to any other circuit element. And opens are important because no current will flow through an open circuit. If you introduce an open circuit intentionally, then perhaps you could use it to measure the voltage drop across an element because no current is going to be flowing through it. You can measure a voltage drop. But if you introduce an open circuit unintentionally, again, your circuit is not going to behave as you intended it. So now take a moment and look at this circuit to identify the short and the open. Circle them, and then we'll work them together and identify the short and the open. Remember that a short has the same starting node and ending node as another circuit element. So let's look at the starting node for resistor R4 and the ending node for resistor R4. Notice that this line has the same start and end node as R4. So current is going to flow through this short instead of through this resistor R4, which is fine if you wanted to take R4 out of the circuit. But if R4 needs to be in the circuit, then you have to recognize that you've shorted it out. The open, on the other hand, is here, across resistor R6. No current is going to flow because these terminals are not connected. They're not closed. Current will only flow through a closed loop. Now, perhaps you want to measure the voltage drop across R6, and this open would be fine. You could attach leads of a voltmeter to these two terminals, and that would be fine. But if this was unintentional, the circuit wouldn't behave in the manner that you wanted it. The key concepts that we have discussed in this lesson are: first, remember that wires are lines that connect circuit elements. Wires meet at junctions, but circuit elements meet at nodes. Always distinguish between a junction and a node. Current will always flow through a short circuit. And remember that a short circuit is any wire that has the same start and end node as another circuit element. And current will never flow through an open circuit because current needs a closed circuit in order to flow. Thanks for your attention. I'll see you next time.